Welcome. This video is CCBYNC. Welcome back. We are at the cusp of some very important concepts here in trigonometry. We're going to apply the trigonometric functions to angles of rotation. That sounds a little tongue twister there, but basically we're going to start out by defining sine and cosine a little bit differently. I want them to notice that when we have a circle like this of radius r at an angle theta, what we have here is a triangle representing a point as it goes. And you can see the further we go this way, the smaller x is getting and the longer y is getting. But we can define every point on this circle using a triangle like this. And I want to point out relative to theta, we can now define sine. Remember, sine is the opposite, which is y, over the hypotenuse, which in this case we're calling r. Cosine is the adjacent, that's x, over the hypotenuse, which is r. And tangent is the opposite, y, over the adjacent, which is x. Now, we have three new trigonometric functions now. We have cosecant, secant, and cotangent. All they are the reciprocals of each of these functions. So instead of y over r, the reciprocal of sine is cosecant, which is r over y. The reciprocal of cosine is secant. Instead of x over r, it's going to be r over x. And for tangent is y over x, which means it's going to be x over y. Couple of things that go with this part of the lesson that we need to keep in mind. First off, looking at our picture here, we know that the XY coordinate system, or the Cartesian plane, is broken up into four. Here we have quadrant 1. Here we have quadrant 2. Here we have quadrant. Here we have quadrant 4. And a special note that we're going to want to keep in mind is what lines S-I-G-N-S in these quadrants. In quadrant 1, both x and y are positive. In quadrant 2, x is negative, but y is positive. Quadrant 3, both x and y are negative. And in quadrant 4, x is positive and y is negative. We're going to come back to this often, and we need to really keep this in mind. So you can tell that the signs are going to be governed by which quadrant we're in. So because sine has to do, by the way, r is always positive. X and y can be positive or negative, just depending on where we're going with that. And I want to point out, in quadrant 1, everything's positive, all 6 trig functions. And sometimes, because all are positive in this, we put an A. In quadrant 2, sine is still positive because y is positive, right? We're above the x-axis. So only sine and its reciprocal are positive. Cosine, secant, tangent, cotangent are all negative in quadrant 2. You can see they're all governed by x as well. In quadrant 3, tangent is the only thing that's positive. Tangent and cotangent, it's reciprocal. And the reason is because both x and y are negative, but a negative divided by negative is a positive. So only tangent and its reciprocal are positive. And in quadrant 4, only cosine is positive because cosine has to do with the x. You'll notice y is negative here. And this can form an acronym. All students take calculus. Some people use that to remember that, if that's helpful for you. So let's explore this a little more. We have a point, -3, 4, that's going to be in quadrant 2. -3, 4. So that's right there. And theta in this case, which we don't know what that is, and at this particular moment we don't care. once again, this is point -3, 4. And meaning x is -3, y is at 4. Now, I still need to find r if we're going to find the six trig functions. So to find r, that's going to be the square root of -3 squared plus 4 squared. So r equals 5 in this case. So we're going to use our definitions here to come up with the six trig functions. Notice I didn't need to do plus or minus because we're saying that r is always positive. So sine of theta, which is y over r, y is 4, over r, which we now know is 5. Cosine theta, cosine is x over r. X in this case is -3 over 5. And we can definitely see that x is negative, right? Cosine is negative there. Tangent theta is y over x. So that's 4 over -3. So that's -4/3. The other three are very easy to find. The cosecant of theta is the reciprocal of sine, 5 over 4. Secant of theta is the reciprocal of cosine. It's also negative, 5 over 3. And cotangent of theta is the reciprocal of tangent. That's going to be -3 over 4. Not too bad. Next up, if sine of theta is 3 over 7, and theta is in quadrant 2, so we're in quadrant 2 again, so we're here. Then determine, again, quadrant 2 means that x is negative. Then describe the values of the six trigonometric functions of the angle. Now, what I want to do is come up with a triangle and we know sine is the opposite over the hypotenuse. So this missing x here, I can use the Pythagorean theorem. And when I go to take the square root, I'm going to have to do plus or minus. It's going to have to be minus, pardon me, because it is in quadrant 2, where x is negative in quadrant 2. So x squared plus 9 is 49. X squared equals 40. So x is going to equal negative square root of 40, which simplifies to 2 root 10. And once again, x is negative because we're in quadrant 2. So now that we have that, let's do sine of theta. And just barely cutting it off, we can see sine again is y over r. Y in this case is 3 over r, which is 7. Cosine of theta is going to be x over r. So that's going to be negative 2 root 10 over 7. And tangent of theta is y over x. Y in this case is 3. X in this case is negative 2 root 10. And you can rationalize that if you need to. You'll need to find out if your teacher wants you to rationalize it or leave it as is. Although, I'll go ahead and do it. That's going to be negative 3 root 10 over 20. So the other ones are just the reciprocals of these. So cosecant of theta is 7 over 3. Cosine of theta is negative 7 over 2 root 10. which again rationalized is going to be negative 7 root 10 over 20. This is secant. Secant and cotangent of theta is the reciprocal of here. That's going to be negative 2 root 10 over 3. So let's fix that. That's secant theta. All right. To this one here. If the cosine of theta is negative 2 over 7, now to be clear, cosine negative in quadrants 2 and 3. It also says that the tangent is also negative. Well, tangent is negative in quadrants 2 and 4. So 2 and 3 and 2 and 4, so it has to be quadrant 2. So we have to deduce that. So we are in quadrant 2 once again. All three of these examples were in quadrant 2. And again, that means that x is negative. All right, we're going to set up a triangle again, kind of like what we did before. And if this is theta, then we know that theta is the adjacent. That's going to be the negative 2 here over the hypotenuse, which is 7. And we need to determine what that missing y value is. So if I go y squared plus negative 2 squared equals 7 squared. Now in quadrant 2, y is positive. Positive root 45, which becomes 3 root 5. And again, that's a positive 3 root 5. So here we go. Sine of theta is going to be y, which is 3 root 5, over the hypotenuse, which is 7, or the r, the radius of the circle. Cosine of theta is the x, that's negative 2 over the hypotenuse, which is 7, which we already knew. Tangent theta is y, so that's 3 root 5 over x, which is negative 2. Cosecant of theta is the reciprocal here, that's 7 over 3 root 5. Rationalize, that's 7 root 5 over 15. Secant of theta is the reciprocal here, negative 7 over 2. And cotangent of theta is negative 2 over 3 root 5. And rationalized, that becomes negative 2 root 5 over 15. Not too bad. You just have to get all the pieces of the puzzle to work it out. We are now stepping into a new place here where we are going to now say, what if our radius r here is just 1? And that brings us to the unit circle. This is a huge deal in trigonometry. So now we have a circle, but in this case, the circle, the radius is 1. This is still y, this is still x, this is still theta. Well, if we rebuild our equations, but now r is 1, that's going to change things a little. Sine of so that's y over the hypotenuse, which is 1 in this case. So sine of theta is just y. That is huge. We'll talk more about that in a second. Cosine of theta is the adjacent, that's x over the hypotenuse, which is 1, so it's x. Now, before I go on with these other ones, I want to make a big point. This means that I can replace x with cosine theta and y with sine theta. We'll use that a lot. Tangent is the same, y over x. The reciprocals, 1 over y, 1 over x, and x over y. But the big ones are the sine and the cosine. And you can see tangent theta is sine over cosine. You see that? Y over x. And later, we'll use that a lot more. Once again, I want to point out that in quadrant 1, x is positive, y is positive. Quadrant 2, x is negative, y is positive. Quadrant 3, both x and y are negative. In quadrant 4, x is positive, y is negative. I want to label these points. So the point right here, because it's a unit circle and all of the radii are 1, this is the point 1, 0. Up here, this is the point 0, 1. Now keep in mind, 0 is, the first one is x, which is cosine. The second one is y, which is sine. Back here, we have -1, 0. And down here, we have, these are all points. Here we have 0, -1. That's going to help us to find sine, cosine, and tangent, and so forth of these pieces. So now, the cosine of 90 degrees, so part A. Well, up here is 90 degrees, and remember cosine is x. So what's the cosine of 90 degrees? 0, 0. Part B, cotangent of 180 degrees. 180 is back here at this point, and cotangent is x over y. So here we have x, which is -1, over y, which is 0. Ooh, not good. We actually say that this is now undefined. Some online homework services, they have you put D and E, doesn't the letters D, N, and E. Next one, C. Secant 0 degrees. 0 degrees is right here. And secant, if you recall, is 1 over x. X is 1 in this case, so this is 1 or 1. Not too difficult. Moving on with the unit circle. Remember we have those special right triangles? Well, if you remember, the radius is now 1. This is implying that the radius is 2, or in this case, √2. So we're going to change these. And to get the radius to be 1 here, I'm going to divide each side, cut it in half. So this 2 over 2 is now 1. So this length here is now 1. This is now √3 over 2. This is now 1/2. Now this one, I have to divide by √2. So √2 over √2 is 1. So this length is now 1, but I also have to divide these by √2. And rationalized, of course, that's √2 over 2. That changes things a little. What that does for us is that helps us to figure out what these points are here. So we already started. Let's start with this. This is 1, 0. This is 90 degrees is 0, 1. Back here we have -1, 0. And down here at 270, we have 0, -1. But we can find more points. Here's 30 degrees. Let's see if I can fit all of that. Yeah, I can't. But we're going to be looking at, assuming sine is y and x is cosine. So at 30 degrees, we have the coordinates, looking here, cosine, which is the x coordinate, is the adjacent. So it's root 3 over 2. That's the adjacent over the hypotenuse, which in this case, pardon me, the y coordinate is sine of theta, and the sine of theta is 1/2 over 1, or just 1/2. For the 45 degrees, I can do the same thing. Now I'm over here. The x coordinate is cosine. So cosine is of 45 degrees is going to be here, root 2 over 2 over, so root 2 over 2, comma. The y coordinate is sine. Sine of 45 is the opposite over the hypotenuse. That's again root 2 over 2. And it makes sense that they're exactly the same because we're exactly 45 degrees, right? We're halfway to the 90 degrees. 60 degrees, same way. So the first one, x value, is cosine of 60 degrees. Cosine, if you remember, is the adjacent over the hypotenuse, so it's going to be 1/2. And the y coordinate is sine. Sine is the opposite over the hypotenuse. That's root 3 over 2. Now it's getting a little crowded here, but you can see, look at that, the x and y coordinates for 60 degrees and 30 degrees. See how they kind of swapped out? Now you'll notice we're in quadrant 1, everything is positive. Fantastic. We get to quadrant 2, all of the x values are going to be negative. Now you'll start seeing patterns as we do this, and I'm not going to draw all of them in, but I'm going to go to the 150 degrees. Now 150 degrees, that gives us this angle here, this reference angle of 30 degrees. So now I'm back here, just keeping in mind that cosine is going to be negative in this quadrant. Cosine of 30 degrees in quadrant 2 is x. So cosine is the adjacent root negative root 3 over 2. The y coordinate, which will be positive because we're in quadrant 2, is sine of 30 degrees. So that's going to be the opposite over 1. So they're the same. And I don't have enough room to fill all of it in, but you can see they're exactly the same, but the signs are different. If I do 210 down here, we're going to get something very similar. Again, this reference angle here is 30 degrees, so I'm still back here. This is going to be negative root 3 over 2 and a negative 1/2. You can see the connection. Here we're going to get a positive root 3 over 2 and a negative 1/2. That's the unit circle. We use this a lot. Now what I did was I gave you guys a giant one. And what you can do is you can go through, fit all of that. Ooh, barely. And you can write out all of the points. Again, I'm not going to do all of them. 135 I can do, that's negative root 2 over 2 and a positive root 2 over 2. Down here at 240, this is going to be negative 1/2 and a negative root 3 over 2. So again, I'm using all of these triangles and using the idea that sine of theta is y and cosine of theta is x, the x coordinate. And I would recommend that you go through and fill this whole thing in. Pay attention to the signs, right? Quadrant 3, both x and y are negative. So I'll even draw that in here. Quadrant 1, everything's positive. Quadrant 2, x is negative, y is positive. Quadrant 3, both are negative. In quadrant 4, x is positive and y is negative. I hope that helps.